proof-theoretic proofs of functional completeness for two-intersynistic logic and for bi-intersynistic logic to better understand the difference between the two systems. Another obvious item on the agenda is extensions of two-intersynistic logic to first-order logic. And this is interesting. The co-implication of bi-intersynistic logic can be conservatively added to intersynistic propositional logic. It cannot be conservatively added to intersynistic predicate logic. And my guess would be that the co-implication of two-intersynistic logic can be conservatively added to intersynistic first-order logic. One could have a closer look at the relation to Nelson's logics. One could look at modal extensions of two-intersynistic logic, at its relation to Artyomov's logic of proofs, which is based on the Brouwer-Heisenberg interpretation. And I think it would also be nice if one could prove that bi-intersynistic logic has no single conclusion natural reduction proof system. Thank you.
Could you speak on the microphone, please? Can you go back to the slide in which you showed that Paravic's rule with that for negation of implication is not compositional?
Yeah.
Because I want to argue with this.
Okay. Yeah. Is it here? Yes.
Okay, fine. Now, suppose you write this formula in Polish notation. So it would be negation, implication, A, B, right?
Yeah.
The Polish notation. Which is like a list notation.
Yeah.
If you want, okay. Then for the definition of sub-formula that you take, the usual one, the conventional one, these are a substring of this, which is, without gaps.
Mm-hmm.
That's all. So you have, these are the sub-formula. However, if you go back to Frege, if you take a natural language, when I say I am not mistaken, everybody take that I am mistaken is a sub-formula, although there is a gap, a jump. Now, suppose you define a sub-formula a little bit, just that sub-string, but you allow jumps in the Polish notation.
Yeah.
Then, not B is going to be a sub-formula in this extended sense. And you don't have this problem. So maybe the problem is just that you take the notion of sub-formula just as too narrow way, that's all.
Yeah, that's a good question. I mean, when it comes to natural language, I would perhaps have to say we should all negate as Montague used to negate by saying it is not the case that, instead of just not.
But compositionality is because we can understand from the given to us. In German, I think we don't have to keep the order of words sometimes. You can even split words and still understand.
You can juggle a lot.
And still understand. So compositionality, I think, is something broader than just taking this as an immediate sub-formula, etc. That's what I say. And this might solve many of the problems, not all.
Yeah. Okay, but would you also say that the notion of sub-formula then depends also on the notation, or would you just say it's a different notion of sub-formula?
Exactly. Notation is all these brackets. The Polish notation is is the natural one, or if you want it much more natural. That's why Schoenfeld took it in his book.
Okay. I think at the moment I can just say thank you for this critical comment. I will think about it.
I would just a curiosity. I mean, you showed the normalization, let's say, steps going through.
It was just a very, very partial glimpse at.
Okay. But I mean, I trust that these normalization steps, I mean, indeed follow through. So you have, I mean, a normalization theorem. Now, I mean,
I haven't proved it, but I would strongly conjecture yes.
Okay, so well, then I put another conjecture over your conjecture, and it would be, I mean, provided you have a normalization theorem, then the obvious, let's say, continuation of that research program would be to look at the lambda terms. So I was in fact curious what would happen there.
Thank you for that question. It is a good question because I can answer it. So Anand just before this talk he defined the notion of a good question as the one he could answer. So now I have to jump to the very end of the slides. It takes a couple of seconds. Yes, we're almost there. Yes. Yeah, here we are.
Okay.
So, yes, it is. I couldn't agree more. Yes.
Okay.
So, but if you now have proofs and dual proofs, you have to think about the kind of type lambda calculus you use for encoding the proofs and the dual proofs. Mm-hmm. And my idea is to use a two-sorted type lambda calculus.
Okay.
Very quickly.
Okay, so my question is going to be even better because you don't even have to reply to it. You have to decide if you agree or not.
Good.
I'm going to add it to your list of further work.
Huh?
Okay, can you please go back to the slide when you have these semantic conditions for 2 int?
Yes, I have to jump back a little bit.
Yeah, okay. So, for instance, if in a condition for negation...
Which one?
For any condition that where negation is present, we can exchange these instead of for every, for some. For instance, what would happen if you change whatever it's written for every, in all places, for some? Then what we get is a kind of a dual logic of this one, which is sort of paraconsistent in this case. Okay. So, concerning this possibility of having every or for some, there is something called the society semantics.
Yeah.
I don't know if you are aware of that. If you know this.
I heard about it, but I wouldn't say that I'm familiar with it.
Anyway, this society semantic works pretty much the same as in this definition. And in this case, we are working also with two different consequence relations simultaneously.
Yeah.
So my suggestion would be to add these connections to society semantics to your list of further work.
Yeah. I have also a comment on this comment.
Please.
So if you look at the semantics of co-implication in Heinrich-Brauer logic and biointersonistic logic, then yes, it comes with an existential quantifier. So the conjugation in Heinrich-Brauer logic would be true as state if there's an earlier state where it does not hold.
There is it?
There's an earlier state, so you go in the backward direction of the pre-order or partial order. Yeah.
So you think there's no connection state?
No, you suggested using, instead of the universal quantifier, an existential quantifier. Yeah. And in this Heinrich-Brauer logic, they use an existential quantifier. That was just my remark.
Okay. So let's